Alright, so this is our video for chapter 4.3. Like always, we're going to work inside the chapter review found in your book, this time on page 511. We're going to look at 4 problems starting at number 52. Instructions say, use properties of logs to expand each log expression as much as possible. Where possible, evaluate the log expression without using a calculator. So our goal here is to expand. Okay, so expand means you go from one log to many logs, right? So let me remind you of the property. Log of A times B is the same as log of A plus the log of B. And log of A divided by B is equal to the log of A minus the log of B. You go from one log to many logs. Basically, the rule is, if it is in the numerator, then you're going to add the log. If it is in the denominator, then you would be subtracting the log. Okay, so this is log base 2 of x times y squared, all divided by 64. So how many items do I have here? How many different pieces, basically? We have 1, 2, 3. Therefore, when I expand this, I should have 3 logs base 2. So I have log base 2 of x. Well, he's in a numerator, so this guy is positive or adding, basically. And I'm not going to put the plus sign here because the leading coefficient is 1. Y squared is also in the numerator, so I'm going to add another log base 2 of y squared. And 64, he is in the denominator, so I'm going to subtract log base 2 of 64. And now I must clean it up. So log base 2 of x, he is okay. However, the power of 2 on y becomes the coefficient in front of his log. So that is 2 times log base 2 of y minus, well, 64. Can I simplify this so it's 2 raised to some power? Remember, they said evaluate if you can without a calculator. So 64 is the same as saying 2 raised to the 2, 4, 8, 16, 32, 64. Let me do that again. 2, 4, 8, 16, 32, 64. 2 raised to the 6th power. So this is the same as saying log base 2 of 2 raised to the 6th power. Then, since my base and my argument are equal, in essence they cancel out, right? This is gone and the power drops down, so I'm subtracting just 6. The log goes away. Alright, let's try number 53. Number 53. So this time I have the natural log of the cube root of x divided by e. The natural log of the cube root of x divided by e. And again, they want me to expand. So the first thing you need to do is rewrite the cube root. I need it as a power. So this is the same as saying the natural log of x divided by e, all raised to the 1/3 power. All raised to the 1/3 power. Okay? Which is the natural log of x to the 1/3 power divided by e to the 1/3 power. If the quotient is being raised to the 1/3 power, each piece of the quotient is raised to the 1/3 power. And then I can expand this, right? So I have 2 pieces here, x to the 1/3 power and e to the 1/3 power. X is on top, so his coefficient is going to be positive, so that's the natural log of x to the 1/3 power. E is on the bottom, so I need to subtract his natural log of e to the 1/3 power. Then this power must become the coefficient. So it's 1/3 natural log of x minus, well, what is the relationship between e and natural log? They are inverses, so they cancel each other out and just the power remains. So you may write your answer as 1/3 the natural log of x minus 1/3, or you can write it as 1/3 times the quantity natural log of x minus 1. Same answer, they mean the same thing. Okay, so when it asks you to expand, you need to remember these formulas, these properties basically. And also do not forget that the natural log of e to the x power is just x. And e raised to the natural log of x is just x. These are inverses, so they cancel each other out, and you're left with just the argument here, or just the power there. Alright, let us move on to number 57. Alright, number 57. So it says, use the properties of logs to condense each log expression. So now I want to pull it in together. So I have 1/2 the natural log of x minus the natural log of y. Okay, so I would like to condense it. I'm sorry, one second. Okay, so I have 1/2 natural log of x minus the natural log of y. I would like to condense it, which means now my properties are just backwards, right? So the natural log of a plus the natural log of b, that is the natural log of a times b. And the natural log of a minus the natural log of b, that is the natural log of a divided by b. Okay? So if I'm adding, I multiply, it goes from multiple logs to just a single log. And notice that the coefficients have to be 1. They have to be 1 in order for you to condense. So let us begin with number 57. Alright, well first of all, my coefficient in front of the natural log of x, he is not 1, instead he is 1/2. So in order to get rid of the coefficient, I make the coefficient the power. That is the property, the natural log of a to the, I'm sorry, let me start over. C times the natural log of a is the same as the natural log of a raised to the c power. The coefficient has become the power. So I have the natural log of x to the 1/2 power minus the natural log of y. Now their coefficients are just 1, and I can condense them. Since it is subtracting, let's do it this way. Go from multiple natural logs to one natural log. Then you got to say, all right, this guy right here, his coefficient, he's positive. So x to the 1/2 will be in the numerator. This one right here, the natural log of y, he is subtracting. So that y must be in the denominator. And then if you wanted to, you can further clean it up by saying the natural log of the square root of x divided by y. Both of these answers will work. Excuse me. Alright, one last problem for us to practice. Let's look at number 59. It says, use common logs or natural logs in a calculator to evaluate to 4 decimal places. So now I have log base 4 of 0.863. And they want me to evaluate this with a calculator. Unfortunately, this is in base 4, and my calculator, I'm scribbling and I apologize, calculator, that's horrible calculator. Here we go. My calculator uses base 10 as well as base E, also known as the natural log. Okay, so what we're going to do here is a change of base. And let me, of course, remind you of the change of base formula. So log base b of a is going to be the natural log of a divided by the natural log of b. Or you can say the log of a divided by the log of b. I am accustomed to always use the natural log. Either will work. And they will give you the same answer. It's amazing that the natural log of a is not the same as the log of a, and the natural log of b is not the same as the log of b, but this ratio is equal to this ratio. Okay, so I'm going to use the natural log. So I have the natural log of the argument, which is 0.863, divided by the natural log of the base. Okay, and do I have my calculator on me? I do. So it's natural log of 0.863 divided by the natural log of 4. And that is roughly going to be negative 0.1063 if I round to 4 decimal places. I also will show you that I can do the log of 0.863 divided by the log of 4, and that is approximately log of 0.863 divided by the log of 4. Well, look at that. Negative 0.1063. Same answer. Okay, so that concludes our review of Chapter 4.3. Again, let me know if you have any questions.